Hello students, this is Dr. Pradeep Devhate from Department of Chemistry, Shri RLT College of Science, Akola. This video lecture is on the preparations and reactions of various carboxylic acids. Let's start with the first acid, that is oxalic acid, also called as ethane 1,2-dioic acid or ethandoic acid. It has the formula COOH-COOH, that is, two carboxylic groups are linked with each other. In 1829, French chemist Gay Lussac has discovered the isolation of oxalic acid from sawdust with sodium hydroxide. Oxalic acid occurs in the wood sorrel, that is oxalic acetosella, as potassium hydrogen oxalate. It occurs extensively in plant kingdom. Preparations of oxalic acid. Oxalic acid can be prepared by different methods, and first one is by oxidation of ethylene glycol. Oxalic acid can be prepared by the oxidation of ethylene glycol using chromic acid. See the reaction given here. Ethylene glycol, when treated with mixture of potassium dichromate and sulfuric acid, undergoes oxidation to produce oxalic acid. Ethylene glycol gets converted to the oxalic acid, that is by the oxidation. Next one is preparation by hydrolysis of cyanogen. Hydrolysis of cyanogen using concentrated hydrochloric acid gives oxalic acid. Cyanogen, when heated with concentrated HCl, oxalic acid is formed with the elimination of ammonium chloride. Here we have to heat cyanogen with concentrated HCl so as to get the oxalic acid. Now see the reactions related to the oxalic acid. Previous ones are the preparations of oxalic acid. Now the reactions of oxalic acid. First one, reaction with ethanol, that is esterification. Oxalic acid on treatment with ethanol in presence of concentrated sulfuric acid or dry hydrogen chloride or carbon tetrachloride gives two series of esters. Oxalic acid on treatment with ethanol in presence of either the concentrated sulfuric acid or dry hydrogen chloride or carbon tetrachloride gives two series of esters. Watch the reaction. Oxalic acid reacts with ethanol in presence of concentrated H2SO4 or HCl or CCl4 to form ethyl oxalate with removal of water. This ethyl oxalate again reacts with second molecule of ethanol to give diethyl oxalate. This is the process of esterification where initially oxalic acid get converted to ethyl oxalate and then it is get converted to diethyl oxalate. Next is reaction with ammonia. Oxalic acid reacts with ammonia to form ammonium oxalate, which on heating loses water to give oxamide. See the reaction. Initially, when oxalic acid is heated with ammonia, it forms ammonium oxalate, which on further heating loses water molecules to give the oxamide, which is the diamide. Next to this is reaction with glycerol. Oxalic acid reacts with glycerol at different temperatures to give different types of products. Oxalic acid reacts with glycerol at about 110 degrees centigrade to give glycerol monoformate, which on hydrolysis gives formic acid. During this reaction, glycerol is regenerated. Glycerol and oxalic acid combines with elimination of water and CO2 at 110 degrees centigrade to give glycerol monoformate. This glycerol monoformate then hydrolyze to produce glycerol and formic acid. Thus, here oxalic acid get converted to formic acid at 110 degrees centigrade. Oxalic acid, when reacted with glycerol at 230 degrees centigrade, it gives glycerol dioxalate, which by loss of two molecules of carbon dioxide gives allyl alcohol. Initially, glycerol and oxalic acid combines at 230 degree. There is a loss of water molecule and glycerol dioxalate is formed. This glycerol dioxalate then releases CO2 to form allyl alcohol. Next is the action of heat on oxalic acid. On oxalic acid, heating gives different products. Oxalic acid on heating at different temperatures gives different types of products. On heating the oxalic acid at 95 degrees centigrade, or we can say 95 to 100 degrees centigrade, formic acid is obtained with elimination of carbon dioxide. And on heating the oxalic acid at 195 to 200 degrees centigrade, it is decomposed into carbon dioxide, carbon monoxide and water. See the reactions given here with. At 95 to 100 degrees centigrade, oxalic acid simply releases CO2 and form formic acid, but at 195 to 200 degrees centigrade, oxalic acid totally get decomposed to produce CO2, CO and H2O. Heating at different temperatures, oxalic acid gives different products. Next, preparations and reactions are of lactic acid, that is alpha hydroxy propionic acid, or we may call 2 hydroxy propanoic acid. It has the formula CH3 CHOH COH. CH3 CHOH COH. Now here, as far as the lactic acid is concerned, in 1780, Scheele isolated lactic acid from sour milk. It is formed by the fermentation of lactose, that is milk sugar, by lactic ferment or lactic bacilli. Lactic acid is also found in blood and muscle tissue. Let's discuss the preparations of lactic acid. First, by reaction of acetaldehyde with hydrogen cyanide. See the reaction. Acetaldehyde reacts with hydrogen cyanide to form acetaldehyde cyanohydrin, which on acid hydrolysis using HCl gives lactic acid. Here in this reaction, HCl get added across the carbonyl group to form acetaldehyde cyanohydrin, which is then hydrolyzed. Secondly, lactic acid can be prepared by reduction of pyruvic acid. Pyruvic acid on reduction using palladium or zinc in presence of sulfuric acid or sodium borohydride gives lactic acid. Here pyruvic acid, that is CH3COCOOH, get reduced. Carbonyl group get converted to alcoholic group, that is CHOH. Reduction of pyruvic acid into lactic acid can also be carried out by using sodium borohydride, that is NaBH4, instead of using palladium or zinc metal with acid. Next one is the reactions of lactic acids. Let's discuss one by one. First reaction with ethanol, that is esterification. Lactic acid reacts with ethanol in presence of concentrated sulfuric acid or in presence of dry hydrogen chloride to give ethyl lactate. Lactic acid reacts with ethanol in presence of either the sulfuric acid, that is concentrated sulfuric acid, or dihydrogen chloride to give ethyl lactate. See the reaction. This is the common esterification using alcohol and acid. COH group present in lactic acid get converted to ester so as to obtain the ethyl lactate. Next is reaction with phosphorus pentachloride. When lactic acid is treated with phosphorus pentachloride, it gives lactyl chloride. Lactic acid treated with phosphorus pentachloride to give lactyl chloride. Here 2OH gets replaced by Cl. During this reaction, phosphorus pentachloride converted to phosphorus oxychloride. Also during the reaction, there is a removal of HCl, elimination of HCl. Let us discuss what's the action of heat on lactic acid. Action of heat on lactic acid. On heating, lactic acid gives cyclic ester called lactide. Cyclic ester called as lactide. Watch the reaction. When heated, two molecules of lactic acid undergoes cyclization with elimination of two water molecules to form cyclic lactide, cyclic ester. This is the cyclization of the lactic acid so as to form the cyclic lactide. Next reaction related to the lactic acid is oxidation. Oxidation of lactic acid can be carried out by using different oxidizing agents. See the reaction given here. Oxidation of lactic acid by using weak oxidizing agent like hydrogen peroxide gives pyruvic acid. By using weak oxidizing agent, that is hydrogen peroxide, oxidation of lactic acid gives pyruvic acid. Alcoholic group, that is CHOH group, get converted to carbonyl, that is CO. The same lactic acid, when treated with acidified potassium permanganate solution, undergoes oxidation to give acetic acid. Lactic acid, when treated with acidified potassium permanganate solution, undergoes oxidation to give acetic acid. In previous reaction, there is a formation of pyruvic acid. Here, the formation of acetic acid. Observe the reaction. Here, there is formation of acetic acid along with the elimination of CO2 and H2O. Last one is the reduction of lactic acid. Reduction of lactic acid with hydroiodic acid at 126 degrees centigrade gives propionic acid. Lactic acid get reduced by HI at about 126 degrees centigrade to give propionic acid. At 126 degrees centigrade, when lactic acid is treated with HI, it loses water molecule to form alpha iodopropionic acid, which again reacts with HI to give propionic acid along with the removal of iodine. Dear students, these are the different preparations and reactions related to oxalic acid and lactic acid. For preparations and reactions of other acids, please do watch next video lecture. Thank you. Have a good day.